All right, this lesson is about isosceles and equilateral triangles. Let's see how this goes. I know you guys haven't done this with me before, but pretty much whatever I write down, I want you to write down, and hopefully you can understand. I'll try to make sure that, I have moments where I pause and you have a chance to think. So please make sure that you are listening, you are thinking, not just copying stuff down as I say it. Make sure you're really trying to think with me. Okay, vocabulary. An isosceles triangle. We already know what that is. It's a triangle where at least two sides are congruent. So I know this triangle over here is isosceles because this side is congruent to this side. Okay, the legs. Those are the congruent sides. So this side here is called a leg, and this side here is called a leg. Whatever your congruent sides are, those are your legs. Okay, the base is the other side. So this down here is the base. This whole bottom piece is the base. The congruent sides are the legs, and the other side would be the base. Okay, the vertex angle, this is where your two congruent sides come together. It's the angle formed by the two congruent sides where they come together. So that's our vertex angle. And then the base angles, well, those are the other two angles. And the base angles are always across from the congruent sides. Okay, first thing up to learn. The isosceles triangle theorem. This says if we have two sides of a triangle that are congruent, then the angles opposite those sides are congruent. Okay, so if these two sides are congruent, the angle opposite this, the angle across from this side, so this angle's next to it, this angle's next to it, the angle across from it, angle A, will be congruent to the angle across from this one. So not this one, it's next to it, not this one, it's next to it, but the one across from it, which is angle B. So whenever you have two sides of a triangle congruent, the angles across from them will be congruent. Okay, so let's practice that concept. In this picture, it says that segment AC is congruent to segment BC. So if these two sides are congruent, which two angles would be congruent? Take a moment and see if you can figure it out. Which two angles? So it'd be the angle across from this side, which would be angle A, and it would be congruent to the angle across from this side, which would be angle B. So angle A is congruent to angle B. Okay, let's try another one. This one says if segment AC is congruent to segment AB, then which angle is congruent to which angle? So take a moment, see what you think. So the angle across from side AB, it's not this one, it's next to it. It's not this one, it's next to it. It's all the way across from it. Angle C will be congruent to the one that's across from side AC. So not this one, but all the way across from it, angle B. Okay, then we have the converse of that theorem. This theorem says if two angles of a triangle are congruent, then the sides opposite those angles will also be congruent. So if these two angles are congruent, the sides opposite them, the sides across from them will be congruent. So the side opposite this one, it's not this one, it's next to it. It's not this one, it's next to it. The side opposite it would be this side right here, AC, and it would be congruent to the side across from this angle. So not that side, but all the way across would be side BC. So AC, this guy right here, will be congruent to BC. Okay, let's practice that. It says if angle A is congruent to angle B. So let me give them both one curve. Angle A is congruent to angle B. Which two sides will be congruent? So what side is across from angle A? Side BC. And which side is across from angle B? Side AC. So I know that this side and this side will be the same length. They'll be congruent. Okay, number 2. says if angle C is congruent to angle A, so let's give them each a curve, which two sides will be congruent? Take a moment. Which two sides will be congruent? So the side across from angle A is side BC. So BC will be congruent to which side is across from angle C? Side AB. Okay, so those are our two theorems that we're going to practice on this next set of problems. And so I just have a whole bunch here. Some of them I may not work out all the way because most of you are really good when it comes to equations. So we'll just see how it goes. Okay, so in triangle 1, I know this is an isosceles triangle because these two sides are congruent. So which two angles will be congruent? The one across from this side will be congruent to the one across from this side. So if this is a 55-degree angle, what's this one? 55, because they're congruent, so they have to be the same. Now, what do you remember about three angles in a triangle? What do they add to be? They add to be 180. So 55 plus 55 makes 110. So x would be 70. 110 plus 70 makes 180. Okay, triangle 2. These two sides are congruent, so the two angles across from them will be congruent. So the angle across from this side is x, and it will be congruent to the angle across from this side, which is over here. So if this one's x, what's this one? Now I'm going to set up an equation. What do these three angles add to be? 180. So this angle x plus this angle x plus this angle 90 add to be 180. And of course, a lot of you could probably just think through this and not actually have to work an equation. If I combine like terms, x plus x makes 2x. And then if I bring down the plus 90, that equals 180. I can then subtract the 90 from both sides. If I subtract 90, I get 2x is 90. And if I divide both sides by 2, I get 45. And some of you probably could have just thought through that. If this angle is 90, I know that these two will have to add to be 90. That way the 90 and 90 makes 180. And if these two add to be 90 and they're both the same, then they're both 45. So you could just think about it. Okay, number 3. This time they give us two congruent angles. So I know if two angles are congruent, the two sides across from them are congruent. So the side across from this angle, it's not that one, it's not that one, all the way across. This side here is going to be congruent to the side across from this angle. So all the way across would be this guy. So what do these two tick marks mean? It means these two sides are the same length. So my equation would be 20 equals 3x minus 4. Now let's solve that. I would add 4 to both sides, which would make 3x is 24. And if I divide by 3, I get x is 8. So when two sides are congruent, you set them equal and you solve. Okay, number 4, I ask for two different things. I ask for an angle, and then I also want to know about x, and x has to do with being a side of the triangle. So let's talk about the triangle first, because that's the easiest. 50 plus 50 makes 100, so how much is y? 80, because the three angles always add to be 180. Okay, sides. Notice how this angle is 50 degrees and this one's 50 degrees? That means that these two angles are congruent. So if these two angles are congruent, the two sides across from them are congruent. So which two sides would that be? The side across from this angle is 4x minus 3, and the side across from this angle is x plus 12. So what would your equation be? 4x minus 3 equals x plus 12. If these two sides are congruent, I just set them equal. And then I would solve. Let's go ahead and solve this one. There's going to be some others I won't solve. I need to get my x's on the same side, so let's move this positive x by subtracting it. 4x minus x makes 3x. I'm going to bring down the minus 3, the equals, and the 12. Now what? Add the 3 to both sides, you get 15. Divide both sides by 3, and you get 5. And there's our x. Okay, number 5. I am going to just cover up this triangle on the right side and work with just this triangle over here on the left. I know these two sides are congruent because they both have 2 sets of tick marks. So if these 2 sides are congruent, the angles across from them are congruent. So the angle across from this side is the 50, and the angle across from this side is over here. So if this one's 50, what's this one? 50. And so 50 plus 50 makes 100, so how much is x? X is 80. Now, let's do the same thing for the other triangle. Let's cover this left guy up. I know these 2 sides are congruent, so the angles across from them will be congruent. So which angle is across from this side? The y. And the angle across from this side? Over here. So if this is y, what's this one? Y. Because they're congruent. They have to be the same. So what do the 3 angles in the triangle add to be? 180. So this angle y plus this angle y plus this angle 100 add to be 180. And then I could solve that if I wanted. Now, let's just think through this for a second. If this is 100 degrees, what do these 2 have to add to be? These 2 would have to add to be 80. And if they're both the same, what will they both be? 40. So there's just thinking through it, but this is what you would get if you actually solved that equation. Okay, number 6. We have to figure out where to start. So let's see here. I know these 2 sides are congruent, so I know the angles across from them are congruent. So the angle across from this side will be congruent to the angle across from this side. Now, could I figure out what this angle is? What do you know? How far is it from here to here? 180. So if this is 110, what's this guy? 70. If this one's 70, what's y? 70. And if these are both 70, 70 plus 70 makes 140. So x would be 40. How are you doing? Are you understanding? Is it making sense? Let's give a smiley face. Yay, having fun. Okay, let's go to 7. I know that these 2 sides are congruent, so the angles across from them are congruent. So what angle is across from this side? The 2x. And which angle is across from this side? The x plus 30. So if these 2 angles are congruent, what's the equation? 2x equals x plus 30, etc. I'm not going to solve it. Let's move on. Number 8. I know these 2 sides are congruent, so the angles across from them are congruent. So which angle is across from this side? The 6y plus 1. And then I need to figure out the angle that's across from this side. Well, it's over here. So if this one's 6y plus 1, what's this one? 6y plus 1. Okay, and what do we know about the 3 angles in our triangle? They add to be 180. So this angle, 6y plus 1, plus this angle, 6y plus 1, plus this angle, 21y plus 13. Oh no, I can't squeeze it in. All add to equal 180. And I'm not going to solve it because most of you are really good with that. Okay, I want to see if you can do number 9. Take a minute and see if you can figure out number 9. Actually solve the equation. Okay, since these two sides are congruent, I know the angle across from this side is congruent to the angle across from this side. So if this is 2x, what's this one? 2x. What do you know about your three angles? They add to be 180. So this 2x plus this 2x plus this 4x all add to be 180. Okay, if I combine like terms, 2x plus 2x plus 4x makes 8x. And then I would divide both sides by 8, and I get 22.5. That's about the third time we've got that answer in just the last couple weeks. Okay, let's skip 10. It's basically just like all the others. All right, let's try the next page. Okay, with these, I am told that if I have an equilateral triangle, all three sides being congruent, then the triangle will also be equiangular, which means all the angles will be equal. So if it's equilateral, it's equiangular. This says the converse of that. If it's equiangular, if all the angles are equal, then all the sides will be equal. It'll be equilateral. Now, how much are all the angles again if they're all the same? They would all be 60 degrees, because 60 plus 60 plus 60 makes 180. Okay, so looking at triangle 1. I know that this is equiangular because all the angles equal, so that means all the sides equal. So I need to set up an equation to solve. So let's start with these two equaling, because I know that these two sides equal. So 10 equals 5x. What's x? X is 2. Okay, now I need to set up an equation so I can solve for y. So I can set these two equal. I can say that xy equals 10 also. Well, would we just say x was? We just found out that x was 2. So if I plug the 2 in, then it's really like saying 2y equals 10. And if you divide, you get y is 5. Okay, let's skip 2 for a moment, and let's go down to 3. This time, I have an isosceles triangle, so I know that the angle across from this side will be congruent to the angle across from this side. Okay, can you figure out what z is? These two add to be 180, so if that's 135, z would be 45. And if z is 45, what's x? It would be 45 also, because they're congruent. So how much does that make y? Y is 90 degrees, because 45 plus 45 is 90, so this would have to be 90, so they all add to be 180. Okay, let's see here. Let's go down to number 7 for a little bit, and then I'll backtrack. Number 7, I see that this is an equilateral triangle. I know that all the sides are equal. Well, what do you know when it's equilateral? When all the sides are equal. I also know all the angles will equal. So this angle will be congruent to this one, which will be congruent to this one. And what are all these angles again, if they're all equal? They're all 60 degrees. So this angle here is 60 degrees. So what can your equation be? 3x plus 15 equals 60. This has to be a 60-degree angle if it's equiangular. If I subtract 15 from both sides, I get 45. And if I divide by 3, I get 15. I know, you guys are probably getting tired. You probably had enough. So a lot of these pictures here are kind of repeats of some things that we practiced on the other page. So let's look at 8, though. 8 has an equiangular triangle because all three angles are equal. So what do you know when all three angles are equal? All three sides are equal. So I need to try to set up an equation that I could solve. What do you think I could set up? I can't set these two equal because it won't work. I won't be able to get an answer. But I can set these two equal or these two equal. Doesn't matter, it's all the same. So I'm going to set 10t equal to 7t plus 15. And then I could solve that, etc. Okay, maybe just for time purposes, I will save number 2 and number 5 for when we get back to class, because those are a little harder to explain. So I'll save 2 and 5, but if you would, for class, come back with number 4 done because it's like a lot of the problems we did on the previous page, and come back with number 6 done, because it's also like a lot of the previous problems we did on the other page. And then we'll go over and we'll see how you did with everything. Was that fun? Smiley face. Thank you.